Hey guys, welcome back to the channel. Sorry for the lack of uploading the past couple days. Just been busy with work and school got a little crazy, but we're back at it. So in this video, we'll be talking about the ideas behind slope and why they're kind of important for calculus and other concepts. I did create an Instagram video channel or page. That's what I'm looking for. Sorry. Which the link will be in the description as soon as I get the chance to. Also, don't forget to drop a like on the video, subscribe to the channel, and hit the notification bell for more content. So let's start talking about slope. So in a previous video, I believe it was the linear function video, we talked about the slope of a line. So we talked about linear functions, and they're in the form of f of x is equal to mx plus b, which is the equation of the line, where m is slope and b is the y-intercept. We decided we said the y-intercept affects how it goes up, so it affects the up and down, also known as the verticality in math. But we really didn't talk much about slope. I just told you it was the steepness. All right, but what does it really mean? All right, so we know on the graph of a line it's the steepness. If we draw a graph, the greater slope is, the steeper it is, the less the slope is, the less steep it is. If that makes sense. So this is m greater than 1, m less than 1. But the idea behind it is, but there's more to it. So let's take a look at rates of change, because we define a lot of mathematics, like calculus, as study of rates of change, and we care about how things are changing over time. And we'll cover some of the topics mentioned today later on when we cover more in-depth of functions, and we'll also cover more some of the topics in physics and others. So we also look at this. So we look at the slope of the line in math, not only just for linear functions, but also like in calculus. If we want to know the slope at this point, how much is that? What's the slope of this line at that point? Or notice the slope of the tangent line, or the instantaneous rate of change at that point. So we define slope as the rate of change. We could say the slope is the rate of change. Now, if you guys remember in the previous video, all right, so slope is rise over run, meaning we need 2 points. So if we need 2 points, that means it means it's the average rate of change. Sorry about that, guys. All right, so pretty much the slope of the line is the average rate of change, and that steepness tells us the rate it's changing. Some functions it's constant, some functions it's not. And so in linear functions, the average rate of change is constant throughout the function, but it changes based off of how the value of the slope. So linear functions have linear constant rate of change. All right, and also it's with respect to whatever quantity we're trying to find. So with respect, in this case, to the x-axis, it's the change in y with respect to x. We also see like in calculus we say the slope of the tangent line with respect to x or with respect to y. With respect to time, it just really depends. And so if we're given 2 points, so looking on this graph, this black marker's dead, but I think it'll be good. No, it won't be good. Let's grab this blue one. Sorry about that, guys. And so if we call this a f of a, or f of b, b f of b, and a f of a. Okay. If m is equal to rise or run, pretty much it's or delta y over delta x. This delta means a change. So essentially, we have the y values or the values of the function evaluated at the x value. So it'll be f of b minus f of a over b minus a. That's how we find the average rate of change, pretty much given multiple points, which is equal to the slope. All right, so this also defines another thing we call the difference quotient. So let me fix this real quick. Grab that marker. This is also known as the difference quotient. Okay, which will be its own separate video. And another form of it, which we'll prove in that video too, is f of x plus h minus f of x all divided by h. All right, so let's not worry about that for now. And also, if we take the limit of this specifically, as h approaches 0, we end up finding the instantaneous rate. Okay, so the average rate of change pretty much means we have an interval. So over here, this is an interval, which is why we need 2 points. Whereas this instantaneous meaning just 1 point in time. All right, that's not important right now. We'll talk about that when we get to calculus, because that also defines the derivative. But pretty much, this slope allows us to find the rate of change on any interval of a function. So say if we're given a curve, grab a new sheet. So say we're given a curve, this curve. Okay. And we want to find the rate of change. Pretty much on this interval. All right, draw lines there, stop it there. Pretty much these 2 points, this is the average rate, this line here signifies the rate of change. And that rate of change is the slope. Okay. And so pretty much you guys are probably thinking, all right, we get it, Swiss. You said it a couple million times in this video already. The slope is the average rate of change. But why is that important? All right, so let's look at a physics standpoint. So say we have a car. I'm horrible at drawing. Excuse my bad drawing. And it's moving with respect to time, a distance. So starting from 0, and it goes x meters. So pretty much x meters. Pretty much this car at any point in time, we could find its velocity, so we could find its change. So a change in position would be x. And so we could define that speed, its speed or it also known as its velocity with direction, if we specify direction as a change in position over a change in time interval. So pretty much this is the average rate of change of position over respect to time. And acceleration, if we know our velocity, acceleration, or the rate the speed is changing, is the average. We call this v bar. We'll talk about that when we cover physics. We call this a change in velocity over a change in time. So instantaneous rates of change are everywhere in sciences. So just a quick recap. All right, guys. Just a quick recap. So pretty much, so in a previous video we talked about the slope of graphs. I just barely mentioned it. I didn't go in depth with it. So pretty much, if a function has so the greater the slope is, the steeper the line gets, and the less the slope is, the less steep it gets. The easier it is to walk on. Pretty much, imagine a person walking on it. If you guys can't see that. All right. So we also in the broader picture, though, moving past linear functions, we call this we call the slope the rate of change, and basically the slope that we're covering now is because it's rise over run, or change in x over change in y, or change in y over change in x. We call that the average rate of change, and then we just divide it as 0.2. So this is also commonly written as y2. Move that up a little bit for you guys. Minus y1 over x2 minus x1. Okay, pretty much we define the slope as a change in the y values. So it's second point minus the first point. It doesn't really matter as long as you keep the same idea. Keep the convention the same, and y2 minus y1 over x2 minus x1. And which also defines the difference quotients, which we'll cover in a separate video. And from and we apply this everywhere, from physics, from chemistry to physics to biology, on how, but in mainly physics, on how things change with respect to time. I'll see you guys next video.